One-dimensional motion. As we look at our surroundings, we will find many objects at motion and many at rest. In a real sense, motion and the state of being at rest are profound topics. Let's try to have a better understanding of these subjects. Consider a man sitting in a park as a squirrel runs by him. The man is at rest with respect to his surroundings. The squirrel is in motion with respect to the man. Now, consider the earth and the moon. With respect to the moon, the earth is in motion, and so the man is also moving. Here, the moon is a frame of reference. Therefore, an object is said to be in motion if there is a change in the position of the object with respect to the frame of reference. So far, we've discussed motion and frame of reference. Let's now understanding the meaning of distance and displacement. A bus moves from destination A to destination B. In its course, it changes its direction constantly and reaches destination B. In the process, the bus has covered a distance of 2000 meters. The length of the path covered is called distance d travelled. Here the moving body has only magnitude. No direction and hence distance is a scalar quantity. Now, let us consider that there is an alternate route which takes the bus to the destination B in the shortest distance, that is 1500 meters. The straight distance between the initial and the final positions of a moving body in a particular direction is called its displacement. Here, the moving body has magnitude in direction. Hence, displacement is a vector quantity. Let's now discuss speed and velocity. Speed is the distance travelled by a body in unit time. Consider an object moving from destination A to destination B at a certain time t, that is 600 seconds. The distance d between the point is 2000 meters. Let's calculate the object's speed. Speed is equal to distance d by time t. 2000 by 600 is 3.3. The SI unit of speed is meter per second. This is represented by the symbol ms to the power of -1 or m/s. When we calculate the displacement of the object between the same points per unit time, we will obtain its velocity. That is, velocity is the rate of change of displacement. So velocity v is equal to displacement by time. That is, 1500 by 400 is equal to 3.75. The SI unit of velocity and speed is meter per second. What happens when a body moving in a certain direction changes its speed suddenly? Let's consider two vehicles moving in parallel with uniform velocity, that is 10 meters per second from point A to point B. Suddenly, one vehicle increases its velocity, that is 15 meters per second in 3 seconds, and speeds off towards point B. As the velocity of the vehicle has increased, it is said to have accelerated. Acceleration is calculated as the rate of change of velocity. That is, acceleration A is equal to change in velocity by time. Here, change in velocity is 15 meters per second minus 10 meters per second, which is 5 meters per second. T is equal to 3 seconds. Therefore, acceleration A is equal to 5 by 3, which is 1.6 meters by second square. Things to remember. Motion is the change in position of an object with respect to a frame of reference. The length of the path travelled by a moving object is called distance. Distance is a scalar quantity. Displacement is the distance travelled by an object with a certain magnitude. Displacement is a vector quantity. Speed is the distance travelled by a body in unit time, and velocity is the rate of change of displacement. The SI unit of velocity and speed is meter per second. Acceleration is calculated as the rate of change of velocity. The SI unit of acceleration is meters by second square.